The third and final form of a quadratic that we're going to show you is what we call intercept form. And we learned standard form of a quadratic, which was similar to polynomial standard form, and then we learned vertex form, which simply gave us directly the vertex of the quadratic. This time we call it intercept form because what the intercept form is going to do is it's going to give us our zeros of the function. It's going to give us the x-intercepts directly. Now, very similar to vertex form, you can see here we're going to use a P and a Q to represent our x-intercepts in this particular setup. Now, the A value does just like it did before. Positive or negative opens up or down. Bigger or smaller makes it steeper or wider, so that acts the same way as it did before. However, the P and the Q are going to act just like the x minus h did. So it's going to be opposite of those, whatever those values are. And we're going to pair up the P and the Q with a 0 to create the actual x-intercepts. Now, very important concept here is that we know that those points are on opposite sides of the quadratic function because they're symmetrical across the axis of symmetry. And so since that's the case, if I mark these 2 points, we know that that axis of symmetry has to run halfway between them. This is going to give us an x value of some number, and that is going to be the x value of the actual vertex. And so that's technically what we need to find last. Since we can basically are given the intercepts, we just need to find the axis of symmetry and then the vertex. And so you can see here in example problem number 3, we're given x plus 2 and x minus 4. Of course, the negative in front of this tells me that it's going to be opening downward. So I have a visual idea of what the graph should look like. And then we can just simply find our P and Q values and create x-intercepts. And so you can see here we have negative 2, 0 and 4, 0. And of course we can simply plot those on the x-axis. Now, those will be a certain distance away from each other, and in this case we're looking at roughly 6 units away from each other, so the axis of symmetry has to be in the middle of that, or roughly 3 units away from each point. And so once we identify that axis of symmetry, we then know that the x value lies at 1, and that is going to be the coordinate of our vertex. And so we can simply evaluate this function for 1, and it'll give us our y value. And when we do that, we have a y value of 1, 9, or excuse me, about y value 9 and a vertex of 1, 9. Now, if you look really closely at this graph, the vertex is an awful long ways away from the x-axis, and so we could probably sketch this pretty comfortably without having any additional t-chart points. Now, if you wanted to, you could be more than glad to t-chart a couple extra points and get a little better visual. Now, I'm going to recommend to you, the closer and closer that vertex gets to the x-axis, the more t-chart points you're going to want, just simply because it'll give you a clearer picture. And we may see that in a later example. So go ahead and move on down the notes and work the next set of sample problems using intercept form. So before we work a couple samples here, something that you may have noticed is that between the vertex form and the intercept form and standard form, there's many different ways for us to move back and forth between the 2 types, between the 3 types of quadratic forms. Now, the intercept form is what we would simply call the factored form of a quadratic. So if we took the standard form and factored it, you would end up with the intercept form. And so the vertex form is what we call a form after we complete the square, and that's a process we're going to learn a little bit later in the unit. So if you took the standard form and completed the square with it, you would create the vertex form. Now, to go from intercept back to standard or vertex back to standard, we could simply just multiply the terms back together, and of course, if we're in the intercept form, that's the old foiling process or distributive process. So be comfortable with moving back and forth between standard form and vertex or intercept form. That's going to be an important process in this unit. So let's take a look here at these intercept form graphing problems. Here we have just a pretty straightforward problem. We have to identify our intercepts first, and so I'm going to do that. And we have a 3, that we're going to match up with a 0. We're going to have a 1 that matches up with a 0. Remember, the 3 and the 1 do not go together. They're the zeros of the function. They give us two separate points, and so that gives us 3, 0 and 1, 0. And of course, the axis of symmetry is going to be directly in the middle of that, and so that's going to be the vertical line of x equals to 2. Now, that's a very important part right there, because we need to be able to evaluate this function at f of 2. And when we do that, when we plug 2 in for x, what we're going to get is a -1. And so that's going to give me a vertex of 2, -1. So 2, -1. Now, here's a problem with this method sometimes. You can't just graph that, because even though we know it's standard, you don't have a real clear view of where that vertex is going to go. And so what I would like you to do is possibly t-chart an extra point. In this case, I'll just t-chart 0, which is going to give me 3. Now, when I do that, I go 0 and 1, 2, 3. That's also going to give me a symmetrical point on this side, and that gives me the 5 points that is necessary to get a clearer picture of the intercept form. Alright, and so that's graphing a quadratic with an intercept form. We have one more example here that we're going to work on. Now you can see the a value equaling to 2. We know this is going to be a bit steeper than the normal one. Now we have opposite signs here. We have x minus 1, x plus 1, so I know that I'm going to have one of them is 1, 0, and the other one is -1, 0. And that makes our axis of symmetry pretty straightforward. Now our axis of symmetry in this case is the y-axis. Now if we ask you to write that as an equation, you must write it as x equals to 0. Very important that you understand how to write vertical lines as an equation. Now, in finding the vertex, we just need to evaluate this for f at 0. And when we do that, we get simply a value of -2. And then we can plot 0, -2. Now again, this doesn't give us a real clear picture of where we need to be. So a t-chart with another point would be good. And I could either go to a +2, I could go to a -2, it's not going to matter. And when I do that, I get 2 and then 6. And of course, I'm going to have the -2, 6 as well. And so you can see that that's a much steeper quadratic. Alright, and there are your examples of graphing an intercept form.